Welcome everyone today to a tour of our neighborhood, the neighborhood in space. And before I begin, I'd like to remind everyone that it's important to recognize why space matters and why exploring near us on planet Earth is really significant. This is where we will go as people. And since we live in space, what's happened to our neighboring planets is actually extremely germane to how we understand ourselves. In fact, one of the themes I will have today is things we've learned about Earth by looking at our nearest neighboring planets. That starts with Mercury and Venus, continues through our own moon, and goes on to Mars. So I'm going to be talking about that part of the solar system. And again, right now is a really pivotal time for understanding this region of the solar system, because this is where some of you may get to go. So it would be really pretty cool. It's been a generation since any human being has gone back to deep space. So we're going to talk about Mercury, the moon, Venus, the Earth, and Mars. These are the worlds that formed in the same neck of the woods as our planet. Now, a lot of people forget that the planets were all born in a rather tumultuous event about 4.7 billion years ago. A lot of energy, condensing matter, probably a lot of dark energy and dark matter that we don't understand yet. And it led to these planets. And one of the important things to remember is, while we look for other Earths, and here's our Earth, we have to remember that our Earth may not always look this way. So the hallmarks of our planet, the water planet, the life planet. Why is it named Earth? People always ask. In fact, water is inextricably linked to everything we do. But if you stripped off the water of our planet would look remarkably, in some ways, like the planet Venus. And so one of the things we do as we study the inner solar system is we do comparative planetology. So here's the Earth. I've unloaded the oceans. You can still see the islands in Australia, the 90 East Ridge, and many other features. And realize that our solar system is really a very interesting place because of how the planets have developed. Our planet developed into the water planet. Now, this little slide shows something rather embarrassing about how we see ourselves. Here's the Earth, and we have a time series for the planet Earth based on the history of life. We're a living planet. So we have Eocambrian or pre-Phanerozoic, and all these eras defined by fossils and things like that. Very important. We've developed similar things based on other indicators for the moon and now Mars and Mercury, and we have none for Venus. So our neighboring world, Venus, 90% of the size of our own planet, we haven't developed that kind of paradigm. This is a real kind of embarrassing thing. It would be like having a sister and not knowing what she really looks like. I don't know whether that matters to you, but to me as a planetary scientist, I worry about not understanding this planet. So we're going to come back to Venus. But we're going to start with the innermost solar system briefly, because we're learning about it very dramatically, move to Venus, the moon, back to Earth, and on to Mars. And I hope you'll at least be inspired by what we've learned in the last couple decades, because that's the lifespan of which a lot of the new data has really borne fruit. So right now, as we speak, a mission known as the MESSENGER mission is inbound to the planet Mercury. And this mission is one of the most challenging in the history of women and men, because it's trying to get to Mercury the cheapest, safest way, and actually orbit a planet where the temperature cycles are the most extreme we can ever imagine on a spacecraft. In fact, much of the spacecraft is a giant sun shield to keep the temperatures of the electronics so it can do its work. No spacecraft built by women or men has ever orbited Mercury. We've done 2 flyby missions back in the 70s, and now this mission has flown by Mercury twice, changing our view of this world that looks remarkably like the moon. The problem is, that's not the way Mercury works. But this mission won't arrive to Mercury to do its mapping until March 2011. So we're getting ready to unfold the real mysteries of a planet that's about a third the size of the Earth's, where we really don't know why its surface looks so much like the moon. There are theories why it has a magnetic field the way it does. Whether at the poles of Mercury, there are actually ice sheets preserved inside craters. So the MESSENGER mission, built by the Applied Physics Lab, competed by NASA, is our new mission to that planet. And starting in March 2011, we will be peeling back the veil of how the innermost planet in our solar system works. This is the densest planet in the solar system. Okay? It's a factor of 40% denser than the Earth. Now, to get to Mercury, the MESSENGER spacecraft had to fly by and achieve a little nudge from the planet Venus. And that's what we do. We use the energy of the planets in the solar system to allow us to do what we do. This is one glimmer of the new data the MESSENGER is producing. This is a color visible infrared map of the cratered region of Mercury. The colors represent different chemistries. We see areas that are blue, coated with a different type of soil or regolith. We see these large compressive features. We think Mercury puckered because of the incredible thermal load from being so close to the sun. We see fresh craters where you see color patterns of the things that were ejected from them. So there's Mercury. I wish I could tell you how this planet put itself together, because we don't know. However, we have a mission to go. It's not a place we would likely send any of you. Temperature extremes would not be prudent, as a former president once said. So missions of exploration to the planets in this coming decade will revolutionize how we see our innermost planet, Mercury, and move on to other worlds. So this is just one little piece of the data about Mercury that we will have from Global. So let me turn to the planet Venus. How many of us really think about Venus? Let me stop this for a second. Here's Venus in the night sky. You can see it tonight, a bright fourth magnitude feature. It's the brightest thing in the sky other than the moon. This is a winter shot from the last winter. What's interesting about Venus is a lot of astronomers are now coming to think, as we look for other Earths, we better keep our mind's eye open to Venus. What makes Venus interesting? Big, okay. Some of us might think that rocky planets can only get as big as those we have. They get too big, they break apart. They don't have enough internal strength. Secondly, it has a huge atmosphere. If you were standing on the surface of Venus, and I do not recommend that, very hot. If you were, the density of the atmosphere would be slightly, about 10 times less dense than water, and it's a gas. So it's actually a supercritical fluid made of carbon dioxide. So imagine how that kind of planet works. It's more like the gases coming out of the uncapped oil wells down deep in the ocean than anything we can imagine being here on planet Earth. So Venus, the morning star, sometimes the night star, I might add, is really an enigma. Giant atmosphere through our eyes, that's what all we see. A fuzzball, cloud decks. We know those clouds now are partly comprised of sulfuric acid droplets and other nasty caustic chemistry. There have been more than a dozen missions by the nation formerly known as the Soviet Union to explore Venus. The United States has sent 2 missions to Venus, specifically one in the late 70s and one called Magellan. But this is the view you'd see of the super rotating outer atmosphere. Now, in the early 90s, the United States mapped 98% of Venus with a mission known as Magellan using something called synthetic aperture radar. These globe views show the planet seen by radar at about the scale of, the MODIS instrument on our Earth observing system, Terra. And here's a map, and I'll stop this, of one region of Venus, one hemisphere. And the big features you see here are each the size of the United States. They're huge. This is a giant mountain system with rift valleys and other features. And basically what you see here is color-coded topography with radar backscatter. The problem is the scale you're seeing is weather satellite scale. As planetary scientists, as people, we're used to the scale that we feel and touch and walk as geophysicists and others. So the scales we have for Venus aren't enough to tell us what made that. Are all these blue areas places that are low because at one point they were oceans? Wouldn't that be cool? Today, the present conditions for Venus would not support the existence of liquid water. The average surface temperature, 450 degrees centigrade. Average surface pressure, about 100 bars, okay, 10 megapascals. This is not the kind of place you'd like to go. Not the place we're thinking about for human exploration. However, in the story of Venus is a story that we need to be aware of for our own planet. And this is very important. So there's the visible Venus. Big atmosphere. The actual outer atmosphere super rotates. In a period of 2 days, the whole atmosphere goes around, sort of like our Earth's atmosphere. The lower atmosphere of Venus that you see here through the eyes of radar slowly rotates retrograde. So in fact, a day is longer than a year on Venus. Imagine that. Why Venus doesn't have natural satellites? We don't know. Venus doesn't have an obvious giant magnetic field. Why not? Big, hot planets tend to have those. Earth, Jupiter, Mercury. What's going on? We don't know. What made Venus' climate system today hellishly hot, caustic, not friendly to life, possibly superoxidizing? What made it that way? Was it born that way? Very unlikely. It's hard for a planet to be born that way for many reasons. So what made it go into a runaway situation? Again, we don't know. The last mission to Venus was by the United States, which made these beautiful maps, was in 1991 to 1994.